All right, we're going to talk about the law of sines. The law of sines we use to solve oblique triangles. Oblique triangles are just triangles that aren't right triangles. So acute and obtuse triangles are oblique. Okay, the law of sines says that you can, like a over sine a. So the side a divided by the sine of its angle is equal to a side b divided by the sine of its angle, which is equal to the last side c divided by the sine of its angle. Or, just flipped around, the sines over the sides. Okay, there are only certain times that we can use the law of sines, and you must know a side and its opposite angle to use it. Okay? So the first example of that would be angle, angle, side. So if we had some triangle, and we know an angle, another angle, and a side. I don't know why I used S. Let's actually use like. So I know a side. Well, then here I know an angle and its opposite side. Another time I can do this is angle, side, angle. And remember that these can be acute or obtuse. I'm just drawing them. So if I have angle, a side, and an angle. Well, here it doesn't look like I can use it because I have a side and not its opposite angle. But if you have two sides or two angles inside of a triangle, can you find the third angle? Yeah, you can, because they always add up to 180. So all the angles add up to 180. So we can find this opposite angle and use this side and this angle to make a ratio. The last one is side, side angle. And so if I know a side, and an angle, again I have an angle with its opposite side. Alright, so you cannot use side, angle, side, or side, side, side with the law of sines. Okay, so let's look at this triangle, and I want to find all of the angles and all of the missing sides. So first I have to see, can I use law of sines on this? Let's see, I have an angle, and a side. So this is an angle, angle, side triangle. So yeah, I can use the law of sines. My first step is just going to be, since I have two of the angles, let's go ahead and find that third angle. So all of these angles add up to 180. So I'm just going to subtract these two angles from 180 to find this third angle. So I have 180 minus the sum of those two angles, 102.3 plus 28.7. All right, so we see that angle right there is going to be 49 degrees. Okay, and let's start assigning names to each side. So the biggest side, we'll still call that C. Okay, across from that 49, let's call this side A. The A and the B don't really matter. And then the one that we already have will be B, 27.4. So I'm going to use that I know an angle and its opposite side to solve for these other two sides. We can start with A and say, okay, I know that the sine of 28.7 over its opposite side, 27.4, is equal to the sine of A, which is 49 degrees, over A. Okay, so now to solve, I'm going to cross multiply. So A times the sine of 28.7 equals 27.4 times the sine of 49. And then we'll divide both sides by the sine of 28.7. to solve for A. Okay, so after cross multiplying and dividing, A is equal to 43.06 in units, because we don't know the units. All right, let's do the same thing to solve for that side C. So I'm going to use the same angle that I was given earlier in this side. So I can say, okay, the sine of 28.7 over 27.4 is equal to the sine of 102.3 over C. And to solve this, we just go about it the exact same way. We cross multiply and divide. So C sine 28.7 equals 27.4 times the sine of 102.3. Divide each side by the sine of 28.7. Sorry about my handwriting. Sine 28.7. And C equals 55.75. So we found both of the missing sides and the missing angle from before. All right, in our last example, we're going to find all the missing angles and sides of this triangle. As you can see, we have a side-side angle situation here. Let's go ahead and assign names to everything. So this 22, we'll call this side A. This 12 will be side B. And our longest will be side C. So this 42 is angle A. We're looking for angle B, sometimes called beta, and angle C, which is gamma, at other times. So I'm given a side with its opposite angle, so I know that I can use the law of sines. So let's just start. We have the sine of 42 over 22 is equal to, okay, the next thing that I have side B, so I can solve for angle B, is equal to the sine of B over 12. So cross multiply 12 times the sine of 42 equals 22 times the sine of B. Just divide both sides by 22. And we have the sine of B is equal to 0.36. So to actually solve for B, that's going to be the inverse sine of 0.36. So the angle B is 21.1 degrees. Okay, so next, now that we have two angles in the triangle, we can figure out the third. We just take them away from 180. So just like last time, without using the parentheses, minus 21.1 minus 42. My last angle is going to be 116.9 degrees. So 116.9 degrees. And this should make sense because your largest side should always have the largest angle. Okay, so now I've got its angle and I'm looking for its side. I can use either of these angles from before. Since we had to round for this 21.1, I'm going to keep using this 42 and 22 to solve for the C. So I have the sine of 42 over 22 equals the sine of 116.9 over the side C. Okay, once we cross multiply and divide by that sine of 42, we'd have C is equal to 22 times the sine of 116.9 all over the sine of 42. So my last side C is 29.3 units long. And we found all the missing sides and angles of our triangle.